Okay, so this video isn't going to be so much of a instructional video. It's going to be I'm going to go through these questions on this quiz, and the point of it is there's two quizzes that are similar, quiz A and quiz B. I'm going to go through one of them and I'm going to set you the other one. So these questions are all going to be very similar to the ones you are doing, and they probably, I haven't 100% checked, but the questions I did check, they go in the same order. So question 1 is like question 1 and question 2 is like question 2. So you can use this video to help you on the quiz you're doing. There are 17 questions, so I'm not going to say this is going to be a short one, but hopefully that'll preempt if you know question 10 is a problem, skip to where you think question 10 might be. I'm not saying sit here and watch all of it. Okay, so it's growth and decay, it's carrying on with our compound interest work, and the questions towards the end are actually pretty hard, and not stuff we've been taught yet, but if you want to challenge yourself, then this is kind of the way to do it. So starting off with kind of the most simple compound interest gets. So £3,000 is invested at a compound interest rate of 4% per year. What is the value after 3 years? So we're going to do the starting value times by our percentage increase, which is up 4%, so 1.04, to the power of the years. So I'm going to do that in my calculator. Typed it all in terribly, but fixed it now. Okay, and that's getting me £3,374.59. So there we go. Question part A is our correct answer there. We could have probably just took a wild stab that these two weren't going to be right off the bat. Okay, question 2. Our starting value, 13,000, is at an interest rate of 5%, so 1.05, for 4 years. So when I type that in my calculator, I get £15,801.58. It's really important. Remember, this is money, so 2 decimal places. Even though my calculator's giving me more, I'm rounding it. So D is going to be my answer for that one. A car depreciates in value, really important. That means that it goes down. So if it goes down by 10% each year, that means we're actually wanting to find 90%. So when I do my multiplying, it's going to be the starting value times by 0.9 for 90%, because it's gone down 10% to the power of 3. Because of 3 years. And when I do that, I get £3,280, 0.5, but remember, 50, 2 decimal places for money, 50p. And let's just double check which one that is. There we go. This is question 4. I think I'll keep a track just so I don't get lost. House price increases by 12% each year, so that's going to be 1.12, 100% plus the 12%. After how many years will the house have at least doubled in price? So we don't know what the starting value is. So I'm just going to say, well, the starting value is going to be X. Just write out what you would do. X times by 1.12 to something years. And what we want this to be, well, we want it to say 2x or more, because that'll have doubled this x. So what I'm going to do is, well, if we want this to be 2x or more, we actually want this bit to equal 2 or more. So we're thinking, what power do we need to raise 1.12 by to make this a value of 2 or more? Because then we're doing x times by 2, which will obviously double the value. So I'm just going to try out some of these numbers. I'm going to try out A. So 1.12 to the power of 6. That is going to get me 1.97, so that's not double the value. Probably just going to try this to the power of 7 actually next, because I think 9 is going to go too high. 6 was really close. I'm just going to go up by 1. And here we go, 2.21. So after how many years? It's going to be 7 years for that one. 8 and 9 will also do it, but I think they're asking for the least amount of years. So C would be my answer for 7, as that's made that bigger than 2. Question 5. Depreciates by 10 years, so that's going to reference me to 0.9, 0.90. If a car was bought for £4,500, what is a first step in finding the new value? Well, let's just ignore this for now. Just do what you would do. You would do that, wouldn't you? So let's find out one that matches this. This guy here. That one they've just found 10%. That one they've increased. This one they've got mixed up with simple interest and compound interest formulas by timesing by 3 at the end. It's to the power of 3. So this one here. Questions like this, just answer it yourself and then check the answers afterwards. Don't get caught up by staring at the answers. Okay, question 6 and 7 here. Jacket is reduced in a sale by 10%. A customer has a loyalty card for a further 5% off. If a coat, is it a coat? The jacket cost £80 originally. What is the sale price? Well, it is not. It's not 15% off. Do not fall for that trick. And you'll see why. Do it step by step. So 80, well, what is 10% of 80? 8. So after the 10% reduction, so after reduction 1, it'll be £72, because I've done 80 take away 8. And then we want to find 5% of this. And when I do that, I'm going to get £3.60. So I need to do 72 take away £3.60, and that is going to get me £68 and 40 pence after reduction 2. So £68 and 40 pence. There we go. If we just took 15% off, we would have got £68. So you can see it's a different value, and actually they've included that there to make sure you don't trip up at that. But you've just got to do each one separately. You can't combine them, because we're taking 5% off a new value, not off £80. Okay, question 7. A jacket is reduced in a sale by 10%. A customer has a loyalty card. Okay, so similar as before, but we're just wanting to think, well, what is the percentage taken off? If we take off 10% and then we take off 5%, we've already made the claim that it's not that, and we've proved it above. Well, if we just say the price equals to X, if we want to take away, if we want to reduce by 10%, what we're going to do is we're going to times by 0.9. We don't need to say 0.90. We're going to times by 0.9. Because that is 90% left. So I'm going to do X times by 0.9, and that just equals 0.9x. And then I want to reduce by 5%. I'm going to times that by 0.95, because 95% is left if we take away 5%. So I'm going to take this value here, 0.9x, and I'm going to times that by 0.95. So my calculator, I'm going to do 0.9 times by 0.95, and that is going to be 0.855. So that is 85.5%. But we're thinking about, that's the price that that's what you're going to pay. So reduction is what's been taken away from 100 for that, so that would be 14.5%, so this guy here. So again, that's just another proof of why it isn't 15%, doing it in the multiple steps there. And that is compound interest because it's interest upon the new value, not just going straight always off the base value of what it started, the jacket started at. Question 8. So you can see these are getting a bit harder now, and quite a bit more to think about than just running the compound interest formula and really understanding what's happening. An athlete increases the distance she runs each day by 1/10. That's also 10%, isn't it? She runs 2 kilometers on day 1. How far does she run on day 8 to the nearest 100 meters? Well, we're going to do 2 kilometers. That's our starting value. She increases by 10%, so I'm going to times by 1.1 for 8 days, so to the power of 8. So we can see it's the same formula, just in many different contexts. So I'm going to do that. That gets me 4.287 and so on kilometers. So let's have a look what this is closest to. To the nearest 100 meters, that's to the nearest 1 decimal place of a kilometer. So that will be 4.3 kilometers. So there we go. So just another application of our formula. They lost 1/10. That's 10%. Always just think percentages for this. They throw other things in there to try and confuse you and make you think. But you just got to bring it all back to percentages. It loses value, so it's going down. So actually it's a 10% reduction, so that's 90%, and that's 0.9. So that's kind of the process you've got to think before you even start the question. So 15,000 times by 0.9 to the power of something. We don't know how many years yet. We've been asked how many years. And that's going to equal, well, we want it to equal this amount of money. So I'm actually just going to trial and error filling in that box with some numbers. If we weren't given multiple choice, I would still pick some numbers, but I'm just going to start at 5 and see what happens. There is no real better way of doing this than trial and error until you learn some things you don't learn until A level. But trial and error is not a bad way at all because you can very quickly get to what you want. It's not a big time consume. So this one gets me 8857.35. Oh, I've got lucky. 5 works. If it was too big, I'd have gone smaller, and if it was too small, I'd have gone to a bigger power. But actually, that works completely fine. If I was doing this without the numbers here, I'd have guessed it. I always start with like 2, and then if that's way too small, I'll go up to like 10, and then I can kind of go up and down and kind of narrow my options down after a bit. The length of a rectangle is increased by 10%. The width of a rectangle is decreased by 10%. What is the effect on the area? This is a really good question. Well, first of all, let's just think, well, area of a rectangle equals length times by width. So we're going to times these two values together once they change. If we say that let's draw an example. If the question's ever confusing, you're like, this one's a little bit tricky to think, just do an example and pick some lengths. So I'm going to do a height of 1 and a width of 2 meters. Well, if I follow these guidelines and I increase the length, so increase by 10%, my new length is going to be 2 times 1.1, 2.2. And if I decrease this by 10%, that is going to be 0.9. So what is the original area of this? Area equals 2. And what is the area of this new one? It's going to be 1.98. So we can see that it's definitely not no change. It's definitely not an increase. So it must be this 1% decrease, and you can always check that by finding percentage change. Percentage change is the new minus old over old, or you can say the change over the original times 100. So the change is 2 minus 1.98 over the original, which is 2, times by 100. So I'm going to do that in my calculator. That gets me 1. So a 1%, and then you just need to have a bit of knowledge about you and just think, well, it's gone down, so it's definitely a 1% decrease. So you can see how I took a very confusing question there, and just by doing one simple example, I have figured it out. That's not enough to prove it. If you were trying to prove this properly, you'd have to use algebra, but this is a completely acceptable way to do it, and this is the way I would do it myself, even if I wasn't trying to teach. Which multiplier can be used? What question are we on? 9, that was 10. That was 11. I might have a bit of a break and come back to this. Pause it. Which multiplier can be used to find the value after an amount has decreased in value by 8% for 4 years? So when we decrease by 8%, which is 0.08, when we decrease we want to do one takeaway. So that is 0.92 to the power of 4 with 4 years. So that's our one there. This one they will have increased. This one they've got mixed up with their simple interest. And this one they are not doing anything with that 8%, they're just finding 8%. They're not taking it away or adding it on. What was that? 11. 12. Which single multiplier can be used to find the total investment value of £5,000 invested at 3% compound interest per year annum after 2 years? So, what they mean by single multiplier is none of this to the power of. They just want to say, well, what is that number in the middle? So what we would just answer the question like you would normally. We'd say £5,000 times by 1.03 to the power of 2. They're basically asking, well, what is this? So what is 1.03 to the power of 2? Well, that is times by 1.0609. So by doing this, we're actually increasing by 6.09%. And you can see it matches up with this guy here. So that's what we're after. That's the single multiplier. No powers, just one singular number. Question 13. Which formula can be used to find the total investment value of £7,000 at investment of 1.5? So that would be 0.015. So we're going to do 7,000. I've not even looked at the answers yet, I'm just answering the question how I would. To the power of 5. Okay, does anything match up with that? Yeah, this one here. Are these exactly the same? No, that's 0.05. They almost fooled me. That one here. That matches up perfectly with what I would do. Some investment shares increased by 7. What question are we on? 14. Some investment shares increased in value by 7% each year. After 3 years, the value of the shares were that number there. What was the original value? Well, we always just put our original value there, so I'm just going to say, for now, original equals to x. And I'm just going to answer the question how I would. So increasing by 7%, 1.07, for 3 years. And when I do that sum, it's going to equal this. So this is where it's getting harder because we've got to work backwards. If this was something like, so imagine if we had 2x equals to 4. To solve it, you would divide both sides by 2, wouldn't you? So in this case, this is what we're timesing x by. So to get it on the other side and get x on its own, we want to divide by 1.07 to the power of 3. Yeah, it's a bit weird, isn't it? But you can see we're just doing it looks exactly the same as this, but a lot worse numbers. So x equals to 22663.30 divided by 1.07 to the power of 3. And this is why we have calculators. Key is just having confidence to set up the equation with algebra. And then having confidence in your algebra skills, even if the numbers are horrible, that you're comfortable with it. So that's rounded to 2 decimal places. We had some stuff after that, but it never made it round up to a penny. And it matches up with this answer here. What are we on? 15. Okay, so this is where it gets really hard, actually. There's a lot of algebra in here. So this is where I think anyone might cap out, but if you can have any chance at this, it's a really good thing to have a go at. £400 is invested at a compound interest rate of T% per annum. The value of the investment, V pounds after n years, is given by the formula this. What is the value of T? So it's not actually that bad. They're basically saying, well, this is our percentage, isn't it? So they're basically saying, well, what is 0.065 as a percentage? That's the question. That is all the question. They've made it a load of crazy words in there. That's all they're saying. Because they've done the start value times by the percentage increase to the amount of n years. So 0.065, well, that is 6.5%. So this guy here. That wouldn't be the percentage it's got the interest on. That would be the percentage with the start included, the 100% of the start included, plus the 6.5%. Okay. And then final 2 questions. We'll be on 16 and 17. So I'm going to pause it here, and just to get my brain around these last 2, because I've not looked at them in a while yet. Bear with me while this loads up. Okay, so these final 2 questions. Phil is investigating the growth in population of a type of bacteria. At the start of day 1, there are 1,000. Oh, where's my drawing tablet? There are 1,000. So day 1, 1,000. I don't know if that's going to be important, but I always just like to write the information down for myself. Population increases at 50% per day, so if it increases at 50%, I'm going to be timesing by 1.5 at the end of the 4th day. So this one is our starting value, 1,000, times by the percentage increase to the amount of days or years or etc. we're talking about. So that wasn't too bad of a question. And when I type that in, I get 5,062.5. So these questions make it seem hard by throwing lots of science in there, but the actual calculations are exactly the same. It's just decoding all these words. And then this final one looks scary. Let's read it together. So this is the same build-up as before. It increases at 50% and it starts at 1,000. The population of bacteria in the flask at the start of the 10th day is K times, so a certain amount times larger than the population at the start of the 6th day. So what I just want to do, well, I want to find bacteria on the 10th day, and I want to find bacteria on the 6th day, and I want to see how much bigger this one is on the left than this one is on the right. by doing a division. So this side divided by that side. So nothing too crazy, just understanding what to do is hard. So let's just do this. 1,000 times by 1.5 to the power of 10. And this one's going to be 1,000 times by 1.5 to the power of 6. My numbers for each of these are going to be 57,665.039. And this one here is going to be 11,390.625. So if this was like 8 and this was 2, you'd say, well, this is 4 times bigger because 8 divided by 2 is 4. So I'm just going to do the larger one divided by the smaller one. So I'll tag that as how many bigger. And when I do that, I get 5.0625. Aha, beautiful. K equals to 5.0625. So it's 5.0625 times, more times bacteria on the 10th day than the 6th. Okay, I'll upload this as just the written PDF as well. That's what I've done on the computer. Hopefully you found some stuff helpful from that.